Okay, so sometimes you'll hear people talking about, natural chemicals and unnatural chemicals. And well, let's just explain that. Every chemical on this chart is a natural chemical, all right? Every element on this chart, I should say, every element on this chart is a natural chemical, okay? So you can't read an ingredient that contains one of these elements and say it's not natural. They're all natural chemicals, okay? This is a chemical chart of elements. Everything here is a chemical, and they are all natural. We got that? Okay. So first, matter. Matter is defined like this. It is anything that has mass and occupies space. That's a basic, brief definition. Every solid, liquid, gas, and plasma is composed of neutral or ionized atoms, okay? Neutral means no charge. Ionized means it has a charge. It could be negative or positive. An atom, what is an atom? It is the smallest unit of matter that has the properties of an element, you see? Which would be protons, neutrons, and maybe electrons. Or protons and maybe electrons, but gotta have the properties of an element. Without that, it is not called an atom. So an atom is the smallest unit of matter that has the properties of an element. It is composed of a dense core called the nucleus and a series of outer shells occupied by orbiting electrons. Okay? The nucleus is composed of protons and neutrons, and it is at the center of the atom, okay, or of an atom. So you got that? The electrons orbit outside the nucleus, and the protons and the neutrons are within the nucleus. The nucleus is made up of one or more protons and a number of neutrons, okay? Protons and neutrons together are called nucleons. So you don't have to, if you're not speaking about a proton in general or neutron in general, just speaking about the atom in the center of it, you could just say nucleons. You dig? And that's both of them. You don't gotta keep, you don't have to keep saying protons, neutrons, just say nucleons. All right, so the protons have a positive, okay, the protons have a positive electric charge, whereas the electrons have a negative electric charge, okay? The neutrons have no electric charge at all. You got that? So protons got an electric charge, electrons got an electric charge. The electrons electric charge is negative. The proton's electric charge is positive. Electrons are attracted to protons by the electromagnetic force. Protons and neutrons are attracted to each other by the nuclear force. Okay? Electrons are attracted to protons by the electromagnetic force. That's one attraction. Protons and neutrons are attracted to each other by the nuclear force, another force. This force is usually stronger than the electromagnetic force that repels the positively charged protons from one another. Okay? A chemical element is a species of atom having the same number of protons in their atomic nuclei. Okay? That is the same number, or Z. So a chemical element is a species of atom having the same number of protons. So let's say an atom of, throw something out there, magnesium. They're all going to have the same number of protons. Okay, so as you can see, you have the number of the number of protons and neutrons together is called the mass number. That represents A. Okay, X is the actual chemical element. So we're going to talk about carbon. So just look at X as the unknown. We have no idea which element we're talking about. Okay, so now the atomic number represents Z, or Z represents the atomic number, and it's the number of protons alone. All right, so let's move on from there. The atomic number of oxygen is 8 because it consists of 8 protons. So whatever the element is going to have a number above it, and that's going to tell you the number of protons. And each element is identified by its number of protons. As you can see, boron has 5. So if any atom has 5 protons, that's boron. Carbon is 6, nitrogen is 7, oxygen is 8, fluorine is 9, so on and so forth. Chemical elements constitute all of the ordinary matter of the universe. Okay, so the physical matter that we have known to be out there, they are on this chart. They're one of these elements. There's no physical matter that's out there that's not on this chart. So this is why they say they have all the elements. However, matter makes up only 15% of the matter in the universe. The remainder is dark matter. It is not composed of chemical elements, okay? So dark matter is not on this chart, contrary to what people attempt to say. Okay, so the term element is used for atoms with a given number of protons, I already explained that, as well as for pure chemical substance consisting of a single element, e.g. hydrogen gas. So we're looking at the mass number. Okay, the mass number is the number of protons and neutrons in an atom. You combine both of them, and that represents A. Okay, so if you look at the bottom, an atomic number is the number of protons in an atom. Okay, so the mass number means both neutrons and protons, okay, the nucleons together, and the atomic number is just the protons alone. So that can get a little confusing. So the mass number represents the weight of the atom. So when you add up the number of protons and neutrons and you find out the number, that is the weight of the atom. The protons by itself identifies what type of atom you're dealing with. And then you see X. X is the atomic symbol. So that's going to tell you what type of atom you are dealing with. So abbreviation, so it's an abbreviation used to represent atom in chemical formulas. So if you look at C, that represents a carbon atom. 12 is the neutrons and protons added together. So it's 12, and that's the weight of it. And then 6 represents the number of protons by themselves. Yep, so I'll take your question right after this presentation, V-Child. So this atom, this carbon atom, has 6 protons, that's the atomic number. It has 12 nucleons, that's the atomic mass, and a neutral atom. So pay attention, neutral atoms, the protons, neutrons, and electrons are all the same. 6, 6, 6. So this carbon atom has 6 protons, 6 neutrons, 6 electrons, and a neutral atom, okay, neutral. All right, so let's move on. If this atom adds an additional proton, then the element is different. Okay, so we're talking about carbon. It has 6 protons. If an extra proton is added to carbon, it is now nitrogen. Okay, the atomic number is now 7, and that means the atom is no longer carbon, it's nitrogen. Elements are identified by their proton number, okay, by their proton number count. So if an atom has 9 protons now, then you're dealing with fluorines. Just that simple. It changes. It's no longer what it was. If this atom, so here we go, let's go here. If this atom, the same atom, adds an additional neutron, what happens? Then the element type stays the same. It's still carbon. However, the atomic mass or the weight changes, right? Because when you add the protons and neutrons, that tells you the atomic mass, and that's the weight of the atom. So if you got a less, so let's say carbon. Let's go here. So if we add an extra neutron to this carbon atom, then you have still 6 protons, and now you got 1 more neutron. So now that's 7. So now the weight is now 13. But the atomic number, the proton stayed the same. It's still at 6. The neutron number count changed. So it's still carbon. As long as the proton count stays the same, it's still the same element. So this is carbon, a heavier atom. That's all. What are isotopes? Isotopes are variants of a particular chemical element which differ in neutron number and consequently in nucleon number. All isotopes of a given element have the same number of protons, you see? So all carbon isotopes is going to have a different neutron number. It might go up, it might go down, but their proton number will stay the same. They still will be all carbon, right? So we have, so it's easy to determine sometimes whether it's an isotope or not, or how many neutrons you have left in the atom. So carbon is 666, is 12, 6. So it starts off like this. Let me show you again to give you an image. So carbon is 12, 6, right? That means 6 protons. Well, we know already. So whatever the mass is, the atomic mass is, doesn't matter what that number says. It can say 100. If it's carbon, we know that 6 of that 100 are protons, right? And then the other 94 is neutrons. It's just that simple. So you always know the atomic mass by just figuring out which type of atom this is, and then saying, okay, I know that 6 of that number is protons, and the rest is definitely neutrons. Now, when it comes to electrons, the electron count is always the same as the proton count. Well, in a neutral atom, I should say, in a neutral atom. So here we have carbon, 11, 6. The 11 is the atomic mass, and 6 is the atomic number. So if you look at this, we know from the fact that this is a carbon atom, so it has to have 6 protons, but we're looking at atomic mass of 11. So all you do is subtract 6 from 11, and that tells you how many neutrons you got in that particular atom of carbon. And now it becomes an isotope. So when the number of neutrons changes, you have now having an isotope. So that's it. That's a basic understanding of what a chemical element is. And when you look at this chart, you can now understand the numbers. All right. So the top is the proton count on this chart, the periodic chart, and the bottom is the atomic mass. It's the combined or joint effort of protons and neutrons. So VC, my brother, what is your question or sister? I'm not sure, but I think you're a brother. What was the question?